Every server you deploy to a cloud provider sits behind at least one firewall, the cloud provider's network security layer. Most developers know about this one because they configured it to open port 22 for SSH and port 443 for HTTPS. But there are actually 3 layers of firewall between the internet and your Node.js application on a typical cloud server. Each layer operates at a different level and provides different capabilities. Understanding all 3 prevents the scenario where you open a port in the cloud console but traffic still can't reach your app. Layer 1 is the cloud security group or security list. This is an external firewall that controls traffic before it reaches your server at all. If port 80 isn't open here, nothing on your server matters. Layer 2 is firewalld, a service-level firewall daemon running inside your server. It manages iptables rules through a friendly interface. This layer lets you define which services are allowed and control access by zone. Layer 3 is iptables, the low-level Linux kernel packet filtering framework that actually enforces all the rules. Firewalld is a manager for iptables. Both firewalld and iptables rules control the same underlying mechanism. The mental model: think of these 3 layers as 3 locked doors. Traffic must pass through all 3. If any one door is close to a port, traffic can't get through regardless of how the other 2 are configured. The cloud security group or network security list is the outermost firewall. It's managed in your cloud provider's console: AWS security groups, Oracle Cloud Security Lists, Azure Network Security Groups, Google Cloud Firewall rules. This firewall operates at the network level, before traffic reaches your virtual machine. If you haven't added a rule to allow port 80, HTTP requests are dropped by the cloud provider's network before your server even sees them. For a typical Node.js web server, you need the following ports open in your cloud security group: port 22 TCP SSH access. Without this, you can't connect to your server. If you accidentally close this, you lose access entirely. Port 80 TCP HTTP. Required for initial HTTP traffic and for Let's Encrypt's ACME challenge during certificate issuance. Port 443 TCP HTTPS. Required for your web application after SSL is configured. All other ports should be closed. Specifically, port 3000, Node.js, should not be open to the public internet. Users should only access your app through Nginx on 80 and 443, not directly to Node.js. Stateless versus stateful. Most cloud security groups are stateful. If you allow inbound traffic on port 80, the response traffic is automatically allowed without needing a separate outbound rule. But check your cloud provider's documentation, as behavior varies. Firewalld is a firewall daemon that runs on your server. It provides a management layer above iptables, organizing rules into zones and services. A zone in Firewalld represents a trust level for a network interface. The default zone is public, appropriate for servers on the public internet. Other zones like trusted and internal provide different default policies. A service in Firewalld is a named set of port rules. HTTP means port 80 TCP. HTTPS means port 443 TCP. SSH means port 22 TCP. Using service names is more readable and maintainable than specifying ports directly. Firewall CMD is the command line tool for managing Firewalld. Check status: sudo firewall CMD state should output running. See what's allowed in the current public zone: sudo firewall CMD list all. This shows services, ports, and rules currently active. Add a service: sudo firewall CMD permanent add service equals HTTP and sudo firewall CMD permanent add service equals HTTPS. The permanent flag saves the rule so it persists after reboot. Without permanent, the change is only active until the next Firewalld restart. After adding permanent rules, reload to apply: sudo firewall CMD reload. Remove a service: sudo firewall CMD permanent remove service equals HTTP followed by firewall CMD reload. Iptables is the Linux kernel's packet filtering framework. Every rule you create in Firewalld ultimately becomes an iptables rule. You can also manage iptables directly, though this is less common on modern servers that use Firewalld. Iptables operates on chains. A chain is a sequence of rules that incoming or outgoing packets pass through. The 3 default chains: input, packets destined for the server itself; output, packets originating from the server; forward, packets passing through the server to another destination. The default policy for each chain determines what happens to packets that don't match any rule. Common production configuration: input chain has a default deny policy, and explicit accept rules for SSH, HTTP, HTTPS, and loopback. View current rules: sudo iptables lvn. The L lists rules, V shows verbose output including packet counts, N shows IP addresses as numbers instead of resolving hostnames. View rules with line numbers: sudo iptables L line numbers, useful when you need to delete a specific rule. The relationship between firewalld and iptables. If firewalld is running, you should manage rules through firewalld, not by editing iptables directly. Direct iptables changes can conflict with firewalld and may be overwritten when firewalld reloads. Use firewalld for service-level rules and reserve direct iptables editing for advanced use cases that firewalld doesn't cover. The most important concept in this module is understanding how the three layers interact. Let's trace what happens when a user sends an HTTP request to your server. The request originates from the user's browser and reaches your cloud provider's network. Door 1 eCloud Security Group. Does the security list have a rule allowing inbound TCP on port 80 from 0.0.0.0/0? Yes. Traffic is allowed through. If no, traffic is dropped here. The user gets connection refused or a timeout. Nothing on your server matters. Door 2 Firewalld. The packet arrives at your server's network interface. Firewall checks its rules for the public zone. Is the HTTP service, port 80 TCP, in the allowed services for this zone? Yes. Traffic is allowed through. If no, Firewall drops the packet. Door 3 iptables. The packet passes through iptables rules, which are managed by Firewalld. Since Firewalld allowed port 80, iptables has a corresponding accept rule. Traffic reaches the server. The listening application, Nginx, is listening on port 80. The packet arrives at Nginx. Nginx processes it in proxies to node.js on port 3000. All three doors must be open for traffic to flow. This is why I open the port in the cloud console but nothing works is so common. The cloud security group is open, but firewalld inside the server still blocks it. Debug sequence. If traffic isn't getting through, check each layer in order. Cloud console firewall CMD list all iptables L. On some Ubuntu installations, Firewalld isn't installed by default. Uncomplicated firewall may be used instead. For Oracle Cloud Linux and CentOS/RHAL, Firewalld is the standard. Check if Firewalld is installed and running. System status Firewalld. If you see unit firewall.service could not be found, it's not installed. Install Firewalld on Ubuntu, sudo apt install Firewalld. After installation, it starts automatically. If UB is already running and you want to use Firewalld instead, disable UB first, sudo UB disable and then sudo system stop UB. Don't run both simultaneously, they conflict. Start and enable Firewalld, sudo system start Firewalld and then sudo system enable Firewalld. Enable makes Firewalld start automatically on boot. The default Firewalld configuration on a fresh installation allows only SSH, port 22. Everything else is blocked by default. You need to explicitly allow HTTP and HTTPS. Quick setup for a web server. Sudo firewall cmd permanent add service equals SSH sudo firewall cmd permanent add service equals HTTP sudo firewall cmd permanent add service equals HTTPS sudo firewall cmd reload after reload. Verify. Sudo firewall cmd list all. You should see SSH, HTTP, and HTTPS in the services line. Firewalld organizes rules into zones. Each network interface is associated with a zone, and the zone determines what traffic is allowed on that interface. For a cloud server with a single public network interface, the public zone is where you work. This zone has a default policy of blocking everything not explicitly allowed. The trusted zone allows all traffic from associated interfaces. Home and internal zones allow some local network traffic. Block and drop zones reject all incoming traffic. You can see all available zones, firewall CMD get zones. The active zone for your interface, firewall CMD get active zones. Services are predefined port configurations. See all available services, firewall CMD get services. This lists hundreds of predefined services. The ones relevant to us, SSH, 22/TCP, HTTP, 80/TCP, HTTPS, 443/TCP. You can also add individual ports rather than name services. Sudo firewall CMD permanent add port equals 8080/TCP. This is useful for non-standard ports. Rich rules provide advanced capabilities. Firewall CMD permanent add rich rule equals rule family equals IPv4 source address equals 1.2.3.4 service name equals SSH accept. This allows SSH only from a specific IP address, useful for hardening SSH access. Removing access. Firewall CMD permanent remove service equals HTTP removes HTTP access. Always reload after changes. Firewall CMD reload. When traffic isn't reaching your app, the firewall is frequently the culprit. Here's how to systematically debug. Symptom: SSH is working but HTTP isn't. Check Cloud Security Group. Is port 80 open in the Cloud Console? If yes, continue. Check firewalld, sudo firewall cmd list all. Is HTTP in the services list? If not, sudo firewall cmd permanent add service equals HTTP and in sudo firewall cmd reload. Check if Nginx is actually listening, sudo sstlnp grepi 80. If nothing shows, Nginx isn't running on port 80. Symptom, HTTP works but HTTPS doesn't. Check cloud security group, is port 443 open? Check firewalld, is HTTPS in the services list? Check SSL certificate, is the certificate properly configured in Nginx? Symptom, nothing works at all. Can you SSH? If no, check if port 22 is open in the cloud console. This is the panic scenario where you're locked out. If you can SSH, sudo system plus status Nginx, is Nginx running? Sudo firewall cmd state, is firewalld running? Symptom, app works externally but can't connect to itself on localhost. Localhost traffic doesn't go through the cloud security group or firewall's public zone. It goes through the loopback interface, which is in the trusted zone by default. PM2 connecting to a database on localhost should work without firewall rules. Port 22 is scanned and attacked constantly on every server connected to the internet. Bots run credential stuffing attacks against SSH 24 hours a day. Your server logs will show hundreds of failed SSH login attempts from unknown IPs every day. Measure 1. Use SSH key authentication only and disable password authentication. This makes brute force attacks impossible. In /etc/ssh/sshd_config, password authentication no. Then restart SSH, sudo system to restart SSHD. Make absolutely sure your SSH key is in /.ssh/authorized_keys before doing this, or you'll lock yourself out. Measure 2. Restrict SSH access to specific IPs in the cloud security group. If you always connect from the same IP, office, home, only allow port 22 from that IP. This is the most effective SSH hardening measure. Measure 3. Change the SSH port from 22 to a non-standard port. This reduces automated attack volume. In /etc/ssh/sshd_config, port 2222. Update your firewall rules accordingly. Sudo firewall cmd permanent remove service equals SSH and in sudo firewall cmd permanent add port equals 2222/TCP and in sudo firewall cmd reload. This is security through obscurity, not a substitute for key authentication, but reduces noise. Measure 4. Use fail2ban. This tool monitors SSH login failures and automatically bans IPs that fail repeatedly. Install sudo apt install fail2ban. Default configuration works well. Your cloud security group is your first SSH defense. Firewalld is your second. SSH configuration is your third. All three layers work together. A practical troubleshooting scenario. You've set up Nginx on your cloud server. Port 80 and 443 are open in your cloud security group, Cloud Layer 1. When you run sudo firewall cmd list all on the server, you see that only SSH is in the services list, no HTTP or HTTPS. You try to access your domain from a browser and get connection refused. What do? Option A, restart Nginx. The problem is with Nginx, not the firewall. Restarting Nginx won't help. The traffic is being blocked before it reaches Nginx. Firewalld is dropping the packets. Option B, open port 80 and 443 in the cloud security group again. You've already confirmed port 80 and 443 are open in the cloud console. The cloud layer is not the problem. Option C, add HTTP and HTTPS services to firewalld and reload. This is the correct action. The cloud security group allows the traffic, but firewalld inside the server is blocking it because HTTP and HTTPS aren't in the allowed services for the public zone. The commands, sudo firewall cmd permanent add service equals HTTP and in sudo firewall cmd permanent add service equals HTTPS and in sudo firewall cmd reload. Option D, the problem is node.js, not the firewall. The firewall cmd list all clearly shows the issue is firewalld configuration, not node.js. The answer is C. All three firewall layers must allow traffic. The cloud layer was open, but layer 2, firewalld, was blocking port 80 and 443.